Okay, so we want to talk about 3.1 quadratic equations in today's lecture. So first, let's review. What will be the y equal to x squared look like? So parabola, negative x squared, it's what opens down. Okay, and so what did you notice here? The coefficient here is 1, and here the coefficient is what? Negative 1. So here is negative, here is what? Positive. Okay, and this will give us the one very important property. If the coefficient here, which will be a is positive, then the parabola always open up. And when a is negative, it's always open down. So the coefficient of x squared will determine whether the parabola opens up or opens down. Okay. And we also wanted to learn the standard form of the quadratic function. Like this, fx equal to a times x minus h squared plus k. A is not equal to 0. And this in the standard form will tell you that the parabola is symmetric with respect to x equal to h, and where h equal to negative b over 2a. So where does this thing come from? It still comes from the general form fx equal to ax squared plus bx plus c. So the b and a come from this, okay? And the hk here is called the vertex. Where is the vertex? It's actually these points. Okay, so this is called the vertex. And it's also called what? Local maximum or local minimum. And for the first one, this is a local minimum, and this one is a local maximum. Okay. And so the h here is defined as negative b over 2a, and k is f of negative b over 2a. So h is your x coordinate, k is your what? Y coordinate. Because k, the formula for k is kind of complicated, and it will be much easier if you just plug the h into the function and find the corresponding y value. Okay, so this is why k is defined like this. So let's review one of the pictures that we learned for the transformation of the functions. 2x minus 3 squared plus 1. So you start with the parabola, and minus 3 means the right 3, yeah? So minus 3 means the right 3. And the 2, it means vertical stretch by 2. And then the plus 1 means go up 1, yeah? So let's look at the picture. So what is the vertex? Sorry. So let's look at the picture. What is the vertex here? It's right here, yeah? And you can look at the x and y coordinate. So the x coordinate and y coordinate is actually what? 3, 1. So your hk is what? 3, 1. 3, 1 here. And the symmetry, look at what means the symmetry. Means the parabola is symmetric to what line? So, and the symmetry is, you can see, is going through here. It's x equal to, is the vertical line here. X equal to the coordinate is h, which will be 3 here. Okay, 3 here, yeah? So then when we compare with the standard form, so x minus h, here is x minus 3. So what is h here? H is 3. And what is k here? K is equal to 1. So, it also be consistent with the standard form when we draw the picture here. So the vertex is 3, 1, yeah? And the standard form also tells us it is 3, 1 here. Okay, and the symmetry here is x equal to 3, which is h. Okay, so this is an example here, and actually this is one of the homework questions. And if they give you the picture on the left, and so I think I will make it 3. I will wanted you guys to figure out what should we do, what kind of operation should we have here. So fx equal to, so this is the equation of the parabola for the left. What should we have? Should we have plus, minus, multiply, or divide here? So let's look at here. So what did we have here? Okay, so this is, so what is the picture that we are comparing with? The parabola, yeah. So the parabola, it seems like, okay, so shift to the left by 2. Go left 2. As also go down 3. Go to the left. What should we do? We should plus or minus? Yeah, so the formula is what? Plus 2. And plus 2. Oh. Okay, so we plus 2. And what should we do with the down 3? We wanted what? A minus 3. We minus 3. Okay, so then you in the homework you can choose one with the answers here. So it's, but you should be able to notice this is the shift. Okay, so find the vertex and the symmetry here. Okay, so what is the vertex? Vertex is hk, and the symmetry is x equal to h. Yeah, so but this one is what? In the standard form, yeah, in the standard form. So what is this? It's ax minus h squared plus k. So for the x plus 4, and what do we want? Is minus h. So here is what? Opposite sign. So this is what? Same sign. Okay, so here plus, it will become negative. Here plus stay the same. 7, yeah, so because this is minus, this is what? Plus. And then, so what will be the symmetry? Symmetry is what? X equal to h. What is our h? Negative 4. So x equal to negative 4. Okay, so for the next one, if we want to find the vertex symmetry and domain range and everything, yeah, so what should we do? Because this is not in the standard form, then we might want to use the formula. So the vertex, which will be what? hk, which will be, what is h? Negative b over 2a, and f of negative b over 2a. Yeah, so what is a here? Negative 1. B here is 10. C here is also 10. Yeah, so we plug it in. So we have h is negative b over 2a, so it's negative 10, 2 times negative 1, which will be what? 5. And what will be k? Is f of 5. What does this mean? You plug in 5 into the equation, into the function here. So negative 5 squared plus 10 times 5 plus 10. Remember, this negative is outside, so you keep it. Negative 25 plus 50, 25 is what? 35. So what do we have? 535 here. So what is the symmetry? So x equal to what? H. And then it will be what? X equal to what? 5. So what will be the domain? Okay, so how could we draw the picture actually? Okay, so because here A is negative 1, less than 0, so it's open down. Yeah, okay, open down, and we know the vertex is 535. So here is 5, here is 35. So it's opens what? Down. Okay. So this is the sketch of the picture. So what is the domain? Domain means all the x values, yeah? So x, it can go to the left at the most, right at the most. So domain is what? Negative infinity to what? Infinity. What will be the range? What is the minimum? How far it goes downwards? Negative infinity. What is the maximum here? Maximum y value is what? 35. So for the vertex here, is this a local maximum or local minimum? Is what? It's a what? Local maximum value, which will be the y coordinate, yeah, 35. And where it occurs at x equal to 5. Okay. Okay, so this is this question. So okay, so then we wanted to work on one application question. So a farmer has 750 meters of fencing. He does not fence along the river. So find the length and width that will maximize the area. Okay, so this is the picture. So actually, I have already given you the x and the thing. Okay, so what should we do? So let the width be x meters. Then what will be the length? So because the total is what? 750. You have a x here, you have a x here, and then the leftover is what? The total 750 minus x minus another x is 750 minus 2x. Okay, so then what do we want? We wanted to find the area. Yeah, so what will be the area? It's length times what? Width. Yeah, so what it will be? 750 minus 2x times x. So when you distribute, what do you have? Negative 2x squared plus what? 750x. So what do we want? We want to find what? Maximum of this what? Quadratic equation. Okay, so when will be the maximum? The maximum come from the vertex, yeah? Vertex, which will be what? HK. So what is H again? Negative B over 2A. So what is B? 750. You have a negative 2 times what? Negative 2. Yeah, so what do we have here? Is what? 375 over 2. Yeah. Okay, so then this is your x, yeah, x equal to h, yeah. So this is when you have the maximum area. So what will be, so this x is also your what, width. So what will be your length? Is what, 750 minus 2x is 750 minus 2 times 700 is 2 to cancel, so it's 375. Okay, so we find the length and the width that will maximize the area. Okay, are you with me? So here is, because why do we want to, because this is x, this is y. Okay, so this is how you do the word problems. Okay.